Okay, so we're finishing up chapter 2. We're going to do density is where we're going to pick up here. And it's the last little bit of chapter 2. Now, density is the amount of matter or mass in a volume. Keep in mind, mass and volume are two different things. And usually, when we say we have density in 131, we say density is mass over volume. And usually, we also say it's grams per milliliter or grams per cubic centimeter. But usually, would you say grams per milliliter? It's a mass over a volume. And what we do is usually the way we usually find density is we find the grams by putting the grams on a scale, and we find the volume by something called displacement. And so the way it works is like this. Let's say we're trying to find the density of this object. Okay, and the first thing we're going to do is we're going to put it on a scale. And the scale is going to tell us how big the thing is, or how heavy it is. And let's say we got 5.184 grams on the scale. Okay, well, that means I have the grams. Finding the mass is easy peasy. All you need is a scale. And so that's 5.184. That's an 8 on my scale there. Now, finding the volume is a little tricky. If it's a regular object, you can try to get the volume by measuring it, but most of the time what you do is you do it by displacement, and this is how this works. Okay, so I have the grams, and I need the volume now. And so what you do is you take a graduated cylinder that looks like this, and these are in milliliters, and you put some water in it. Let's say we put water in it, it's about like right here. And we say, well, we have to estimate in between the lines, and I would say this is 2.8 milliliters for the volume. And then you take your object and you put it into the graduated cylinder. And so now what happens to the level of that water when we put it in the graduated cylinder? And so we'll try to copy this as best I can. I'm not much of an artist, but I try. And so let's say what happens to the level of that water? Well, the level of that water is going to go up because it's displacing the water. And let's say it goes up to here. And of course, we estimate in between the lines. And I say, you know what, I'd say that's about 4.9 milliliters. So what's the volume? Well, the volume of the object is the difference between what you started with the water level and what you ended up with. Here we go. There's my object that I threw in, and the water level went up. And so the volume of the object, and I'll tell you right now, the volume of the object is not 4.9 milliliters. That's the object plus the water. And so how would you find it? Well, you would go 4.9. Let me check, make sure here. You would go 4.9 minus 2.8. And so the volume of the object is 4.9 milliliters minus 2.8 milliliters. And that gives me, I can do the math in my head this morning, so that would be 2.1 milliliters. That's the volume. And so now we have the grams, we have the milliliters. And so what do we need to do? We need to just go ahead and put this in our calculator. And so we say the density is equal to the grams, which is 5.184 grams. Well, I got that off the scale, divided by 2.1 milliliters. And now we can put that in our calculator. And so I take it and I go, let's see, 5.184, and I'm going to divide by 2.1 milliliters, and I get a calculator answer of 2.4685 and some extra digits. Okay, and that's grams per milliliter. Don't forget your units. Okay, if it's density, it's grams per milliliter. That's your units. And so the last thing that we have to do, of course, is we always for any calculator answer that we calculate, we have to do significant figures. And the 5.184, well, that's 4 significant figures. The 2.1 is 2 significant figures. We always go by the least number of significant figures when we're multiplying and dividing. And so we need our answer to be 2SF. And if we do that, we're going to count across, and we go 1, 2. We look one more over for rounding, and that's 6, which is 5 or greater. And so the 4 rounds to a 5. So we end up with 2.5 grams per milliliter. And so that's our density. Keep in mind, when you're doing these things, you definitely want to have the proper significant figures in any answer that you do. And so let's go ahead and do another one. And so let's say that we had a 9.816 gram object displaces 4.2 milliliters of water to 6.3 milliliters. Okay, and what's the density? Okay, well, anytime we're asked for density, the first thing that we need to do is say, well, you know what? I know what density is. Density is grams over milliliters. And when you write down these relationships, that they're a checklist for you, is what they are. They're a checklist. You look at it and say, well, what do I need? I need the grams. I need the milliliters. Okay, now the grams are real easy to find. That's the 9.186 right up here. There's your grams. And what about the volume? Now this is where it gets tricky, because I don't have a visual up here, but you got to realize, what's the volume? The volume is not 6.3 milliliters. The volume is not 4.2 milliliters. The 4.2 milliliters is the volume of the water before you add the object. The 6.3 milliliters is the object and the water together. So you have to take the difference between the two. And so let's do that. So we say 6.3 minus 4.2 milliliters, always using units. And we go by 2 from 3, that's 1, and we got 2.1 milliliters. And of course, when we're doing addition and subtraction, we go by number of decimal places. And so this is 1 decimal. Here's my decimal right there. And over here is also 1 decimal. And we have a calculator answer, but anyway, we still have to fix it for sig figs, and that's 1 decimal, so we're good as far as sig figs go for the volume measurement. And so now what do we do? Well, I have the volume, I have the grams, see what I mean? You know, you have this relationship and you use it as a checklist. And so now I can go ahead and say, well, you know what? It's 9.816 grams. That's my mass. And divided by the volume, we just found it, it's 2.1 milliliters. And there it is. Now we can go ahead and put that in our calculator. And so we go 9.816 divided by 2.1, and I get a calculator answer, 4.674 and some extra digits, grams per milliliter, always have units. And now we need to do sig figs. And so I have 4 here, 2 there. I need 2 in my answer. And so we go 1, 2. Going to look one more over. 7 rounds up that 6. And so our calculator answer goes from 4.674 to our final answer with correct number sig figs of 4.7 grams per milliliter. Always use units. Okay, always use units. Now, now this is how you find the density of something. But many times we have an object and we want to decide based on the density, how many milliliters is that object if I know the mass, or if I know the volume, how many grams does the object have to be? Okay, now, when we have density, keep in mind, what is density? Density is grams per milliliter. Okay, that's what density is. And so what do you do if you're trying to find the mass of something or the volume of something? And the problems look like this. It would be, what is the volume of 14.98 grams of aluminum, and it has a density of 2.70 grams per milliliter. There it is. So what is the volume of 14.98 grams of aluminum? Now there's a table in the book that has some densities, and that's how I know that the density is 2.70 grams per milliliter. And you can also look them up. If you just look up online and say, what's the density? Google's a wonderful thing. So what you have to do with this sort of problem is I'm looking for the volume, and I have the density. So first thing you need to do with a problem like this is write down the density as a fraction. In other words, as a conversion factor. So I just go ahead and say 2.70 grams per milliliter. And the reason why I did that is because I don't want to get confused by the forward slash on the grams per milliliter up there on the upper right. And so I have that as a conversion. And so I'm going to set this up as a conversion, just like if we're doing nurse math or going from inches to centimeters or whatever. This is a conversion factor. And just because I call it density, I give it a special name, doesn't change the fact that it's a conversion. And so I also need to find out, where's my measured number? Here's my measured number right here. You had to put it on a scale to get the grams. You measured it. The density, the way we're using it, is not a measured number in the sense of you didn't measure it, but it is something you looked up and it was found. It was found at one point. So now what? Well, just like we do all these conversions, we just draw a line and we draw another line, and we always start with our measured number, always, no matter what problem we're doing, no matter what we call it, we always start with our measured number. And I'm just putting a red X here just to emphasize that nothing ever lives in that spot. If you put something there where that red X is, something's wrong. You're starting with the conversion or something. You always start with the measured number. Always start with the measured number. Okay, and now, just like all these other problems that we've done, it becomes a matching game. And so this grams here needs to match a grams here to be able to cancel. Because if it's diagonal to each other, in other words, if grams over grams, it cancels, it goes away. And so I see that grams is on top. That's where grams is. It's the only place where we have grams in a conversion factor. It helps that we have one conversion factor. Okay, density problems are pretty easy in that sense. So I'm going to have to take this conversion, otherwise known as density, and I'm going to have to flip it over. And if I do that, that puts the 2.70 on the bottom with the grams, and it puts the milliliters on top, and then we're done. All we got to do now is put it in our calculator. 14.98 divided by 2.70, and I get a calculator answer of 5.548, and that is milliliters, because that's the last unit that we have here is milliliters. And besides, what's the volume? We were looking for milliliters up there. Okay, so I know I have this set up right, and I can check myself too. Grams, grams cancel, and we're left with milliliters. Okay, it's very important that you're always using units, always using units. And so now the last step, of course, and we never want to skip this step, is we make sure that we do significant figures, and we go over here and we check and see what do we have. We have 4 significant figures here. This 2.7 is 3, okay, and I'm going to copy down that 2.7. I'm going to show you why. Some people get confused. They want to say this is 2. This is 1, 2, 3 significant figures. This guy right here, this 0 here, is a trailing 0. But what do you have? Well, trailing zeros don't count unless you have a decimal, in which case it makes it significant, okay? So you do have a decimal here, and that makes all 3 digits significant, okay? So just keep that in mind. It's not 2 sig figs, it's 3 for the 2.7 grams. And now we can go ahead and take a look here, and we go, well, you know what? It's 4 and 3, so we should have, we're looking for 3 sig figs over here, least number sig figs we're dividing. And so we go 1, 2, 3. I'm going to look one more over. We're going to round up that 4 to a 5. And so this becomes 5.55 milliliters. There it goes. Okay. And so we're treating the density as a conversion factor. Okay. And so we can do the same thing if we want to. We can look at, how many grams would we get for, say, something. So how many grams is 432.6 milliliters of mercury, and I believe the density is 13.2 grams per milliliter. Okay, it's pretty dense. And so I want to know how many grams is this volume here. And so once again, I'm going to say, you know what, that you just need to copy down that density. It's 13.2 grams per milliliter. Okay, just copy it down. You're going to have to use it anyway, but the reason why we copy it is so that we make sure that the grams is on top and milliliters is on bottom when we do a density. Now, if we have to flip it over, we will, just like we did on this problem right here. What did we have to do? We had to take that 2.70 grams over milliliters, and I had to flip it over to get it to work. Okay? So now I'm looking for grams for milliliters. And so once again, we have to decide what's our measured number. It's right here. And we treat our density as a conversion. And, we're just going to go ahead and just draw a line. Here we go. Draw a line. Draw another line. And, of course, we always start with our measured number. And I did. And that's the only thing you start with. And so what comes up next? Well, that milliliters, we have to have milliliters there for it to cancel. Okay, look, it has to be an exact match. Okay, milliliters cancels with milliliters. So where do we have milliliters on our conversion? Right there. It's already on the bottom, so I just copy it down, so it's just going to end up over here. So I say 13.2 grams per milliliter, and I know I have it set up right because milliliters cancels, and I'm left with grams. What am I looking for? I'm looking for grams. And so now I can just go ahead and put this in my calculator, and I'm good. So I say 432.6 times 13.2. It'll help if I turn it on. Let's see, 432.6 times 13.2. And I get a calculator answer, which we'll have to use sig figs on and round, of 5710.32. And that's grams because, well, that's the last unit left. And besides, that's what I'm looking for is grams. And we need to go ahead and do sig figs for this one. And so we say, well, this is 4 sig figs. This is 3 sig figs. And so the least of 4 and 3 is 3. So I need my answer to be 3. Now, this is a good number. I'm going to show you this. Let's look at this carefully. We're going to round this 5,700 and some change. the 3 sig figs. So what are we going to do? We're going to count over. We're going to go 1, 2, 3, and I'm going to look one more over, and all this stuff over here that's back here, don't worry about that stuff. We're just going to look over, and 0 is 4 or less. So we're going to go 571. All right. Now here's the really important thing. You must add in a placeholder. Okay, we got to keep the same size. We have to keep the same size. Now this is 3SF now because it's trailing, but you have no decimal, that's trailing, but no decimal. And so this is 3SF. Now, what I was saying about the same size is if you were just to write down 571, that's 571. This is the number you started out with was 5,000 and some change. It's bigger. It's much bigger than 571. So that's why you have to add in a placeholder so you keep the same size. It's a common mistake when you're first doing these things. And the way I like to put it is if you had say $5,000 in your account, okay, and it's nice to have 5,000 bucks in your account, and you woke up the next morning and you had 571, and you called up the bank and they said, well, we just rounded it to 3 sig figs. I think you would be upset, because if you're going to round that money to 3 sig figs, let's say the government decided they wanted to tax you based on sig figs, and they said, well, everybody gets their accounts rounded to 3 sig figs, and whatever the difference is you send to the government, in which case would be $1. You need to have that 0 on the end, so it's still $5,000 and some change. I hope y'all see that. So, it is pretty important that that when you're rounding these things, that you keep the same size. You need the same size when you do your rounding for sig figs. That was a good problem, man, because that was good because, sometimes that happens. You end up with more digits on that you have to start adding zeros in to make it work. If you have to add zeros in to keep it the right number sig figs, that's what you do, okay? All right, now, that's how you use density as a conversion factor. Nothing beats practice. So you should be working as many of the red problems in the textbook. And of course, you have your reading assignments, and you should be doing those as an absolute minimum. Now, the last thing I want to show you today is something called specific gravity. And this is on your lab as well. Okay, specific gravity, otherwise known as SG. All right, and what specific gravity is the relation of of density to the density of water. Okay, and the way it works is like this. Let's say you have 1.71 grams per milliliter, just some density, and I want to go to SG. Well, what you do is when we say a relationship, usually what we mean is we're going to be dividing. And so what we do is we divide by the density of water. And the density of water, for our purposes, is 1.00 grams per milliliter. And that's the density of water. Now, what happens if you divide something by 1? If you divide something by 1, what do you get? You get the same number. Okay, well, so far not too terribly exciting. But you see, you're canceling units. See, the grams cancel, the milliliters cancel, because it's the same thing over. And what happened to the units? The units went away. The units are gone. Okay? So what's the take home on this? You do not have to divide by the density of water to get it. What you do from a practical standpoint is you just drop the units. Just drop the units. That's all you have to do. So if I have a density of, say, 2.98 grams per milliliter, well, then you get 2.98 grams for the SG. And SG has no units. We just call it specific gravity, okay? Since you drop the units, you don't have any units. And so if you want to know what specific gravity of 2.98 grams per milliliter is, you just say 2.98. Don't overcomplicate these things. These things, chemistry is hard enough. Specific gravity is super easy, super easy. And if you want to go back to density, let's say you have a specific gravity, let's say 1.100, with no units. Let's say you have an SG of 1.10. What do? You just put the units back on. That's all you have to do. You just put the units back on. And so there you go. You go right back to the density. Now, specific gravity is usually measured with something called a hydrometer. And what you do is you have a sample that you put in a container. And this is used a lot for like testing urine. If you work in a nurse, as a nurse, you might have to test urine for the specific gravity, or lab technician would. And it's this long skinny tube with a weight on the end, and it floats. And on this device, you have a scale, and you just read off on the scale, and it might say 1.015, and that's your SG for the urine. This is urine in here. And that's your test, and that's what you'd report as your lab results. So if someone is their kidneys aren't working right, they may have a very high specific gravity, or if they're really dehydrated, because the density of or the specific gravity is going to be higher, the more concentrated the urine is, and if they have if they're really well hydrated, maybe the specific gravity would be low. But that's what you do. You get a sample, you put this device in there called a hydrometer, and you just read it right off. It's a lot easier than trying to get the volume and then trying to weigh it and all that. And that's why we use a hydrometer, because you can read it very quickly in a matter of seconds, particularly if you've had practice. It's really easy to make a hydrometer reading. So what's the bottom line? If you have a measurement of 1.05 for your SG, then what's the density? Easy peasy, right? You just go 1.015 grams per milliliter, and you can go back and forth between the two. So that's a specific gravity. It's much, much, much easier than you might have thought. What happens, though, is if you're asked what the specific gravity is, let's go back to one of these previous slides, and let's take a look at this one, where we did what was the well, that's what's the volume. Let's go back to a previous one where we actually calculated the density. And so here we go. So here we calculated the density, going back, and that's at 9.816 grams. And you can add on here, what's the SG? And this is where people mess up, is that they'll write down things like, oh man, I can't remember. I guess the SG is that last volume. No. It's not. That's a volume. What's the SG here? Well, I'll tell you what the SG is. I look over here. Here's my final volume. Pardon me. My final density. Well, the SG over here is 4.7. That's it. That's all you have to do. That's all you have to do. You just have to take off the units. That's all you have to do. Okay. So that's density, and that's specific gravity, and that finishes up chapter 2. Okay, for our lab. Okay, so what I'm going to do is I'm going to turn off the recording for a moment,